think about the seats like this, by the way? Not like where you're sitting, but the arrangement. You like it? Are you okay? Are you sure? You just noticed that? I wouldn't have noticed though if you'd swapped a boy for a boy or a girl for a girl. I probably wouldn't have noticed. But now I remember where everybody sits, so now yeah, maybe. Why?
Me, it's like determination of sections, so you're separating people by gender.
Do you know that Miss Corner has boy and girl freshman class college?
Miss Corner has what? Yeah, like what if he Miss McGee, what did you say? Slate identifies. Yeah, Slate identifies this, Haney identifies the girl.
I'm not talking about this. Yes. Where can I move? Can you see from the back? You want to sit on that side of Slade? Is that okay? Adriana, can you see a little better if you move back one? Wyatt's so aggravating, isn't it? So aggravating Wyatt. All right, questions. Questions about your homework. The last one, number 8. You just put it in the calculator way. It says negative x to the 4th plus 2. What last thing? Okay. Give me a sec. Let me pull up my Dozier. I know you do not have that flipping computer out looking at what's on his computer. Is it football stuff? Put it up. Yes, yes. Always use, yes, we have enrichment today. Always use X as you describe the intervals. What? I don't know what IXL is. Xylophone.
What does IXL stand?
Well, we don't have Alex access in here, so close it. Okay, negative x to the 4th. Don't tell him LIE, Dozier. Listen, don't sugarcoat what it is. An untruth is an untruth. Okay. Here. Oh my goodness, what am I doing? Look, you're distracting me. I typed it in the wrong place. Negative x to the 4th plus 2x squared minus x minus 2. Sullivan, focus. You asked about this one.
Oh, you gotta walk me. I agree. You now have both of them.
I'm going to hold it for you, just in case you're worried about it being a distraction. Would you ask me yesterday? Would you email me about yesterday?
Oh, yeah.
Okay.
Yeah, what did you email her about yesterday?
Zoom 6. Zoom 6, we're going to find the turning points, yes? It looks like I have a max here. I've got a max somewhere in here, and I know I do because I start going down here, Oh, maybe I don't. I never go back up. Let's trace it and see. Do I? All right, watch my Y values. They're going down. Maybe, I'm looking to see. In order for it to be a minimum, at some point I have to stop going down and start going up, even if it's just briefly. So watch my Y values. They're going down. That's down. Still down. Oh, it did go up ever so slightly. So yes, I have a minimum there. So let's calculate. I have a max, left bound. What, Haney? Closure. There's my max, relative max. So I am increasing from negative infinity to negative 1.107. The y is the value of the function. The x is what you use to describe the intervals. I'm going to just label these points on here so you see. This is a maximum, yes. All right, I'm going to calculate this minimum. Same thing here. Left, right, enter. 0.2696. And then negative 2. Yeah. That's a minimum. I just did because the third one rounded off. It would have been 30. So I just went. But no, you don't have to go that many. They shouldn't be way off, y'all. Did you round it there? That's because you rounded. Yeah, because you rounded to the third decimal place. That's right. Yeah. No, that's a 6. So this is really 0.270 negative 2.130. Probably. Rounded 3 decimal places, yeah. And then this very last one, that max 0.838. Negative 1.93. Actually, 3 places, sorry. 927. All right, so we did all that so that we could identify our intervals. So are y'all ready? Sometimes it's easier if you label them. Increasing, how about from here to here? Where's that one? Decreasing, how about here to here? Increasing, how about here to here? Decreasing. So now we can just label them. We use x's to describe, right, Haney? So my increasing would be from negative infinity to negative 1.107. And then from 0.270 to 0.838. Just the x values there. That's what you got? What'd you get for your decreasing? Negative 1.107. These are not fun, they're nasty. but they're not hard. That's fine. That's fine. Use the X every time. Use the X to describe the intervals. Yep. All right. Y'all ready to move on? That's a what? Stop! Sarah Ann will say my bad. They're supposed to call you back though. Okay. Y'all ready to do zeros? Do y'all need a break and plan? I feel like y'all have been on break since we got in here. All right. Shh. Okay. Only look at the X values when we do this, okay? All right. Do you understand that all of this, as you move left to right, you're steady going up? You agree? So this is one cutoff. In fact, every time you have a maximum or a minimum, that's a cutoff for an interval. Okay? So all you have to do is decide, is it going up or is it going down in that interval? So this is negative infinity and this is going to be positive infinity because I'm left to right, correct? Okay, so if I think about this and I cut this into intervals, from negative infinity until I get to this first point, negative 1.107, is it going up or down? So that's an increasing interval. That's where this one comes from. Now, next section here, from negative 1.107 until I get to 0.270, that's decreasing. So this interval is negative 1.107 to 0.270, and that's decreasing. That's where that one comes from. This one, you sure? Okay. Anything else, anybody else, before we move on to zeros and multiplicity? Chilling? Yes. Always use X. You haven't focused yet. How do you refocus if you haven't focused initially?
Oh, yeah, I'm sorry, y'all. Sorry, y'all. Trying to live with it.
You know, isn't that one by Corey? No, it doesn't. It misses you right here. From about this point over, but from this point that way. But because you're that point over that way.
Yeah, why?
All right. What's a zero? It's the x-intercept. That's exactly right. These are notes, Joe. How many, if you think about, let's relate this back to something we know. We've talked about quadratics a whole lot, right? A whole lot. What's the most number of zeros that a quadratic can have? 2. So it has 2 or fewer zeros. It could have 1. How could it have 1 0? The vertex could be on the x-axis. How could it have no zeros? Above and opening up or below and opening down. So less than or 2 zeros. How many zeros do you think a cubic could have? What's the most number it could have? 3. I appreciate your enthusiasm there, though. If you think about the way a cubic looks, remember we're like this. The only way, in order to ensure the most number of zeros, would be to put my x-axis here. I'd have 1, 2, 3. Huh? What do you mean multiplying 3? Don't try to look ahead yet. It'll confuse you. No, we're not going to do that though. How about, Wyatt, I bet you can get this one. 4. And in fact, can we make a general statement about what we think is happening? It goes up 1 for each degree. So what's the degree of a quadratic?
4.
What is it with 4 today? What's the degree of a quadratic? 2. What's the degree of a cubic? 3. What's the degree of a quartic? 4. So in fact, do you see the pattern that's happening here? The degree tells you the maximum number of zeros. That's actually like the fundamental theorem of algebra. It's a huge theorem for algebra. It is a theorem.
We have to learn it.
Well, you have to know it. You just learned it. You already knew it, yeah. So the degree tells you the number of zeros. And I'm going to say it gives you all the zeros because it still gives you, if you saw the quadratic that opens up but it's above the x-axis, you can still find those zeros. They're just imaginary, right? So you still have 2 zeros. They're just not real zeros. But I do have 2 solutions there. So the degree tells you the number of zeros. Is everybody okay with that? Very responsible, Dozier. Very responsible. What's that put? I'm thinking. It's only this class in third block that has a seat there. Third block is math. Okay. Let's talk about how we find them on your calculator. Quintic. Quintic 5. That's right. 5. Find the zeros. Wait a minute. Oh. Then 6 zeros. 6th degree polynomial. If it does, I don't know it. You left your calculator at home? I was going to say I only have 2. Thank you, Dad. That's very nice. Y'all got those zeros yet? There's the equation right beside my calculator. Right here. Oh, I'm sorry. Why it doesn't count? 4!
4. 4.
Okay. Don't like stuff. I got
Who threw a piece of paper at you? So
what?
Wyatt Thompson threw paper?
I'm telling you. All right, I'm done with it now. I'm done.
Thank you, thank you. Negative x to the 4th plus 4x cubed minus 2x squared minus 4x plus trace. I'm going into calculate again. Second trace. This time, you don't have to maximum this time. Right now, all I want is the zeros. So I'm going to choose 0, which is number 2. Okay. And I'm going to start with this one. So go to the left, enter, and go to the right and hit enter, and then enter one more time. -1. Now I have to be very careful. You didn't go left and right of the zero. Make sure everybody can get this. Everybody got -1 on your calculator? Everybody good? This is going to be a heavy calculator test. Okay, so there's that one, right? Now, the second one's going to give us a problem because the zero sits on the x-axis instead of crossing through. When that happens, and we're going to talk about what causes that to happen, but when that happens, I can't calculate the zero. I have to calculate that minimum there and then check to see if it gives me a zero. Yep. Let's see what happens. See how my y value is 0? That tells me it was an actual 0. But because it doesn't shoot through the x-axis, I can't use the 0 option and calculate. Okay? That always throws everybody. It doesn't happen often, but it does happen, so I needed to address it. Make sure. So can everybody get this value for the second 0? Okay? You couldn't get that 0. Don't choose 0. When the 0 sits on the axis.
Honestly, it looks like it is.
When the zero sits on the axis, when it doesn't bounce, when it doesn't go through, but it just bounces off, you have to use minimum. Huh? You got 0 from this. That's fine. It's a calculator right. So this would be 1, 0. Remember what that e with the negative number that follows it means. Different calculators are going to do a little bit different things. The 1, I would. All right, try. Sound like a dad. Okay, try the last one. Try the last one, see if you can get it. The last 0. Make sure you can calculate it. Make sure you can do. Make sure you can do left down, right down. Make sure you can get that value there. So you can try it, Dozier. You gave your calculator weight, yeah. It is 3. So we got x equals -1, x equals 1, and then the last one should be x equals 3 whenever you calculate it. We just did all the zeros. This was -1, this was 1, and this was, yeah, I rounded it. All right, everybody okay on finding zeros? This is technically what we've already done with quadratics. We're just adding, we're expanding to polynomials instead of just quadratics. Y'all okay? All right, let's crank it up a notch. What? I'm telling you. Linear factors. You love a good brain break. All right, so we can use the zeros to write the factors of the polynomial. So again, let's go back to a quadratic. Let's think about how we do it with quadratics, and then we'll apply that to, that's okay. We're going to talk about it. All right, if I had something like x squared plus 5x minus 6, what are the zeros algebraically? What are the zeros of that function? What would you do? Do the factor thing and set each piece to 0, right? So, isn't that what you just said? That's not what you just said. Okay, so to find the zeros, I would do equals 0, and I would factor. Does that factor? It does. What multiplies to -6 but adds to +5? 6 and negative 1, right? Multiplies to negative 6, but adds to positive 5. So negative 6 and 1. What if I started with telling you that these were the zeros? Could you then write it in factored form? So if I told you that I had a quadratic that had zeros of 2 and 5, how could you write that in factored form? Those are the linear factors. It's just factored. That's all it is. It's just factored. X minus a 0, not the number 0, but x minus a 0, a place where it crosses, is a factor of, this is a separate example. If I told you that those are zeros, could you write the equation? We're just going backwards from what we've been doing. Getting there, Haney, I'm getting there. I forget I can't hand you the homework early. What? What are you talking about? Are you trying to multiply it out? You don't have to. Well, stop. That's factored form. Those are the linear factors. Okay. I'm not going to blow your mind, but I'm going to. Write it in factored form.
I almost.
Write it in factored form. Not all do it at the same time now. It does. 1040. And we have enrichment. Sorry. I can't sit like that for that long if I don't make y'all sit like that. All right, so all I did was take an X out first. But I'm not done. It's just form because it's not form. No, I'm not done. I'm not done. I'm not done. Yeah. No, we're going to leave it out there. We're going to leave it out there. 0 is essentially, when you have X as just an X on the outside, you could really write that as X minus 0. Because 0 is crossing over at 0 there also. But let's go ahead and factor. I don't have a leading coefficient, so the factor should be easy for me. What multiplies to negative 15 but adds to negative 2? So what are the zeros here? 5, negative 3, but also 0. Does it make sense that there are 3 of them? Now, let's go back and think about our quadratics for just a second. Say again? Because it was to the third degree. That's exactly right. Oh. You didn't mean to say what? Oh. Oh. Well, great day. Okay. What are the zeros here? How do you know? How'd you know that so quickly? X plus 5. So could I write it this way? So you're saying that there's only one zero. What does that mean graphically? The vertex is on the x-axis. 1, 2, 3, 4, 5 here, and it does something like this. Agreed? So it doesn't actually go through it. It's just on top. And in fact, this is what we call a repeated solution. Repeated solution. Because that solution happens twice. And in fact, I call that number 2 its multiplicity. So the multiplicity is how many times it's repeated. Now here's what's cool about multiplicity. Depending on the value of the multiplicity, it tells you what the graph is doing. If the multiplicity is even, is the multiplicity for -5 even or odd? Why? 2. How many times does it happen? Twice. All right, so look, x equals -5 has a multiplicity of 2 because it happened twice. How many times that number is repeated? If it was x plus 5 to the third, the multiplicity would be 3, right? Are y'all following me? And it's odd. If it is even, okay, just wait just a second, it's gonna all come together. Do you understand what multiplicity is? How many times it happens? So if I had x plus 2 to the third times x plus 1 times x minus 5 to the fourth, I have 3 solutions there, right? X equals -2, and that has multiplicity what? Multiplicity of 3 because it happens 3 times. There's 3 of those factors. And then I have x equals -1 with multiplicity of 1, this one. And then the last one is x equals 5, and that has multiplicity of, there you go, I did that one for Wyatt. That's exactly right. That's exactly right. The exponent that's hooked to it or how many times it occurs, okay? That's the multiplicity. If that multiplicity, so this number, this number, this number, if that multiplicity is even, then it bounces off the x-axis. What do I mean by that? I mean the vertex sits right there smack on the axis. It never crosses over. It touches it and shoop, goes back up. Or touches it and shoop, goes back down. But if the multiplicity is odd, it goes through the x-axis. It's how many times the factor is repeated. You're trying to do, somebody take Haney's homework sheet from him. Great day. All right, look. Tell me the zeros of this polynomial. -7. Tell me the multiplicity of each one. What's the multiplicity of -2, 1, and 3? Now tell me the effect it has on the graph. In other words, now stop. Is it bouncing or going through? Bounce, through, and through. How did you know that? Even or odd. That's all it means. Okay? Are y'all okay? Well, y'all are not okay. Y'all are not going to be opposite side of each other. Yes. No. You just set it equal to 0 and solve. Where's your neighbor's son?
I got an X.
Let me grab it and see what happens. What was my equation?
X plus 7 squared. 2x plus 1. X minus 6.
X plus 7 squared. 2x. Not graph that
Because it's
It should be bouncing at -7. Well, it should be.
It's just the math ain't nothing.
That's not true. Yeah. Yeah. Not the 0, the multiplicity. Yeah. It's not the 0, it's the multiplicity. Multiplicity will never be anything but a whole number. Look at this one.
Never mind.
Multiplicity of 2, multiplicity of 1, multiplicity of 3. X plus 7, you set each piece to 0. If the multiplicity is even, all right, guys, listen. Stay with me. We're almost done. Dozier, give him his phone. All right, listen, Sullivan. Stay with me. Focus. Y'all focus with me just a little bit. I told a little bit of a story.
She told him not so.
Unintentionally, yes, but regardless. A polynomial has a 0 at x equals -6 with multiplicity of 2. And a 0 at 2 with multiplicity of 1. Write a polynomial in standard form that could represent this. It's easy to write it in factored form.
But then once you get back to the right.
You don't have to. I was just showing you. That's not in standard form. Emma, why is that not in standard form? It's factor form. Still not standard form. I might be going a different way than you. No, I told y'all this. I told y'all that story about why I teach. No, I do. That's why I started teaching. Okay, you have your homework. What happens if you have something that has multiplicity of 5? Yes, you would have to write it 5 times. You have 2 of them on your homework that are problems like this. 1 or 2? Says what? That doesn't, no, don't. Number 2 is what Haney says. He doesn't stop if you don't. I'm just picking. All right, what are the zeros? 0, how'd you get that one? Every piece goes to 0. So 0. How'd you get that, Davis? That's exactly right. What's the multiplicity of 0? What's the multiplicity of negative 1/3? What's the multiplicity of negative 7? What's the effect of 0? Through. 1 is odd. 1 is odd. 2 is even. 3 is odd. We're looking at multiplicity here. So 2 is bounce. No, it's even or odd. That is not true. Good.